I am now live. Look at that. I'm Shelley Stahl. I am the Vice President for Open Science Leadership at the American Geophysical Union, and I am mostly your host for this meeting. Didn't realize I'd be on the big stage, so hello, big room. For those of you online, there are about 1,000 people in this room. The excitement around the topic is they're standing in the back, you in the back. There's some room up here in the front. Come on up. Hybrid is fun. We have an incredible program for you today. So let me introduce it. First of all, this is a joint session between the Fair Data Maturity Model Working Group. Many of you are aware of the recommendation that we put out a little bit ago, and my co-chair, Keith Russell, will be talking about that. And also the PID Instrument Group, and they really delighted to have this partnership with them. And what we were looking towards is, you know, in the challenge that we all have about our data being as fair as possible, other objects as fair as possible, but in this case, we're specifically thinking about data. How can we ensure that? And we have this concept around deepening the work that we're doing on the framework, strengthening that work, and then also widening that work. So this particular session is widening. How can we have the data be as fair as possible coming from the instrument where it was actually created? And interestingly, we don't actually have a working group, tell me if I'm wrong, here at RDA that's actually working on that. So this is sort of like a secret BOF. So if you feel like I'm here, but I've never heard of this before, well, that would be correct. So this is the beginning. We have a few examples, knowing that there are many, many kinds of sensors. We have speakers that are going to talk about airborne LiDAR, speakers that are going to talk about chemical analysis, some work that's happening in a new project that's happening in the Amazon, having to do with those sensors and the data being captured. 1, 2, 3, and Charlie, hopefully, is on, who's going to talk about environmental sensors, specifically out of Chicago and the challenges that they have there. So I will check to make sure Charlie made it on. He's our only remote speaker. So let me tell you a little bit about who you're going to be seeing. So Keith Russell is going to talk about, come on up, Keith. He's going to talk about our Fair Data Maturity Model Working Group. And I'm really delighted to have him as co-chair along with Edith Herzog. And we have a new co-chair, Sarah Jones. Sarah had to go to, I think, Helsinki, but she was here earlier this week. So we're really delighted to have her join us, followed by Rolf Kral, who's here from the Instrument PID group. His co-chairs, Marcus Stocker and Louise Derrick, as well as Ted Haberman, have done much of their work, and we'll be introducing that here for a few minutes. And then we'll go into our speakers, and I'll introduce them ahead of their time. So we'll hold on that for the moment. Keith, take it away.
Thank you, Shelley. First of all, question, so very happy news. Yes, our virtual attendees all logged in and ready to go. So we are very excited about that. First of all, I'm wondering how I can advance the slides. Is there a clicker or it's not? Perfect. Wonderful. Thank you very much. There we are, because this slide would have made Shelley's life a lot easier. There we are. We have an actual agenda for today. First of all, welcome everybody. Wonderful that you could make it. I'll give you a very brief introduction to the Fair Data Maturity Model Working Group, and to give you a bit of context and a bit of perspective about why we care and what the work we've done over the past few years. And then I'll hand over to Rolf, who's here next to me. Cast our mind back to 2019, when the Fair Data Principles had been around for a while, but they were really starting to gather momentum. And you saw a lot of organizations were very enthusiastic about them and started to pick them up in a range of different ways. And they, of course, they're principles, which means that they are not very strict and not very defined. And what you saw was that a lot of organizations and initiatives were interpreting them differently, making different versions for different disciplines. And we said, well, actually, it might be worth seeing if we can get some commonality across that and identify the commonality and a joint approach on that. So we looked at different assessment frameworks, compared those and said, well, what can we do in bringing together all the stakeholders, looking at those existing approaches and expertise to build a jointly agreed fair data maturity model. What we didn't aim to do was develop yet another evaluation method or revise or redesign the fair data principles. So we started back in 2019 and brought together, first of all, a landscape report of the existing landscape. Then with the community went through a number of phases to actually identify what are key core criteria that everybody can agree on, and tested those out. And that resulted in the publication of the version 1 of the model. And then we also collected some feedback from the sector on that. We've now gone into maintenance mode because we've been around longer than the 18 months for a working group, and we are maintaining that outcome, that recommendation. But what we're also doing is exploring, as we're going through the conversations about the fair data maturity model, what is needed, what is actually necessary on top of the model to make it all happen. And that is the reason why we've also initiated this session. So you can find the model here, and you'll see it's more than just the piece of paper. There's also a testing framework, so you can test it out yourself and see what it looks like for you in the case of your data set. Oh, there we are. One thing I'd like to raise, and we try to raise it time and time again, adoptions. It's great to see that it's being adopted. It's quite surprising sometimes to see it is adopted, because we often don't hear about that. And all of a sudden in a presentation, you see, oh yes, we use the fair data maturity model. And you go, oh, wow, that's brilliant. That's excellent. We'd love to hear about that. So if you are using it, please let us know. Just shoot us an email, anything will do. And we're happy to have a chat with you about it and see how you've adopted it, what that's meant for you, if you found it useful, if there's any feedback you have for us. So that's all for me. I hope this is a bit of a useful context for why we care and why we've initiated this discussion. I'd like to now hand over to Rolf, who will provide a bit of an insight into the persistent identifiers for instruments working group. Thank you. There we are. That's all for you.
Yeah, hi. So I'm Rolf Kral. I'm from the Persistent Identification of Instruments Working Group. And yeah, so again, we are also a RDA working group. We had our 18-month lifetime, and so as the mission statement you can see in the above in the top. So we are seeking to explore a community-driven solution to globally unique identification of measuring instruments in the science. We have been active from March 2018 to October 2019. So we had our wrap up in Helsinki. And one thing it's important to mention, so our scope is the instrument instances. That means the real physical objects that sits in some lab. It's not about instrument models, it's not about instrument types, it's about the individual instances. And what we did, we formulated a metadata schema to identify instruments, and we explored some potential solutions with existing PID infrastructures. And we tried out 2 different candidates with the EPIC consortium that provides handles, and with DataSite DOIs. And now we are in the same situation as the fair data maturity model working group. We are in maintenance mode. That means we are looking into the products that we delivered and try to keep them alive. And oh gosh, there's something missing in the slide. Okay. Oh, okay. No, it's there. Nice. So why did we do all that? So the idea is, as I said, to create persistent identifiers for instruments. And the idea is, so what are the benefits of that? The idea is to link data with the instruments that created them, so to have some provenance information in the data. But also from the other perspective, from the perspective of the instrument providers, we of course want to track the scientific output of a particular instrument and to explain our funders what was all that money good for that they spent in providing that instrument. Some groups might use it for logistics and mission planning. And one important thing that is also, say, related to fair data is the automatic aggregation of information. You get much richer metadata for your data if you can collect information about the instrument that created them. And so in a nutshell, it is another node in the so-called pit graph that we all discussed so much. So I took the opportunity to provide some links into the fair data maturity models. So the instrument PIDs might be relevant for the fairness of the data in these aspects. So the fair data maturity model requires that metadata includes reference to other metadata. And that in that case, it means might be a reference to the instrument's PID. We want to have provenance information recorded into the metadata, and that is another point in that bit graph. And furthermore, so indirectly, if you have the opportunity, so if the instrument PID could link to more metadata, say, describing the instrument, like specifications of that instrument, you could aggregate that and use that to provide even more metadata about the data set that you created. A few words on the metadata schema. I won't go through all these attributes. The most important thing is the idea for the metadata schema was to provide the information to identify the instrument. We are not we don't have much information and for much attributes for a technical description of the instrument. That would not be feasible because, of course, the metadata schema needs to be generic and needs to work for all the scientific disciplines. And that could not, so a detailed technical description would not be feasible on that generic level. But an important thing is that it allows to link other sources of information to that PID, and therefore you could include your community-specific metadata by linking them from the PID. And then I wanted to just to show some practical example how we do it at Helmholtz-Zentrum Berlin für Materialien und Energie, where I'm coming from. So we opted to use datasite DOIs for our instruments. We operate a synchrotron light source. We have beamlines and experimental stations. And we provide these beamlines and experimental stations with DOIs. And we made our life easy because we already had some instrument database that is used for the user portal of our facility. And we just took these existing database pages as the landing pages for the instrument. So we didn't create them explicitly for these datasite DOIs. And here is one example of such a landing page that we have in our user portal for one instrument. And we have here now a DOI that points to that instrument. And here's an example for a data publication that shows how to link the data with the instrument. So the data side schema has a related identifier, and we link the instrument with as a related identifier with relation type is compiled by from the data set metadata, and we also provide that links on the dataset landing page, so to directly link to that instrument. And yeah, that was what I wanted to present.
Thank you. Fantastic.
It's
Oh, there's parts. Okay, thank you. Hopefully it still works. Yes, okay, great. Thank you, Ralph. That's wonderful. And let's get started with our speakers. So I'd like to introduce to you our very first speaker, Professor Pedro Carrera from the University of Sao Paulo. Professor Carrera works within the School of Engineering, and he and I are both part of a really fun project funded by the Belmont Forum called Parsec. And Pedro, I'm going to let you take it away. I'm going to fix this for you while you say hello.
Hello, everybody. Thank you, Shirley Stahl, for this invitation. I'm very happy to be here, my first RDA. I'm very excited to be here to share a lot of ideas. I'm very, very, very happy to be here. So I will talking about some projects that you are involved that have intense collect data in Amazon, involved a lot of instruments. So it's okay. I will talk two large projects that we are involved. The large scale biosphere atmosphere LBA. This is a long-term collect data. I will talk about a little bit about this, and mainly about the instrument that is involved in this project, typical instrument. But I will be very short about this project because it's very new. This project is 30 years ago. It started 30 years ago. I will focus on the Amazon phase. Amazon phase just started in 2022, and we need more insights. We need more collaboration in this project. So the large-scale biosphere atmosphere, the acronym is LBA. The objective is long-term Brazilian initiative to generate scientific data to better understand the functioning of Amazon. All of this data has in the stored in the published in different repositories. Part of them is in Doc in Cornell, others in Max Planck, German, and the others in Brazil. We use FTP. It's not good infrastructure. We are going to, our challenge in this project is develop a better infrastructure to organize this data that we have in Brazil and to support some infrastructure for data analysis. We are working exactly in this moment in this project related with this. Sorry. And in this project, each tower has many instrumentation. We have large towers. For example, in this project, you have Atto. Atto is 323 meters. Is higher than Paris Tower, just to have an idea. And they do have a different instrument in different positions to collect the plume that cross this tower. We have different towers spread over different positions, different sites in Amazon. And this is kind of the instrument that you have. We have a different, this instrument is put in different high position in these towers. So I will talk more in this moment related with this project. This project is Amazon Phase. It is acronym for Free Air CO2 Enrichment in looking for world ecosystem scale. The hypothesis of this project, the scientific problem is we must understand what the impact of the climate change, the extreme climate in the Amazon, in the forest Amazon, deforestation of Amazon, because if Amazon could fix CO2, maybe we can have so much deforestation. We have different scenarios, and if we could have more sink carbon, we can have this scenario. If you don't have, this is this scenario. So we must understand how is the behavior of CO2 in the Amazon. There are some hypotheses that the Amazon cannot more retain the biomass. We are decreasing the capacity to retain the biomass. This is one hypothesis for this, but you must confirm this. This project, the idea is to study this problem. The idea to understand the future of the forest based on climate change, deforestation, forest degradation, and fires. This project started with the Brazil, German, USA, just starting 2022 to build our infrastructure. We are just starting to building this kind of infrastructure here. We are building 7 infrastructure like this. This is a tube that injects CO2 in this forest, in this piece of forest here. And there are a lot of sensors inside to know the behaviors of some plants inside of soil. And we have some requirements about data. We are looking for this process related with instrumentation, implemented instrumentation, collect the data, processing data, describe the metadata, archive, archive with some monitoring all the process, with the focus on data quality, and all the time you have metrics to evaluate all the process. So we have many people involved in this project. The PIs, the coordinator this project is David Lapola from Brazil, and the Anja Ramin from Tune University. This is the site where we are here. Just here is the South America, Amazon area. This is the site where you are going to install the 7 plots. This is the LiDAR of this area. We have different positions. It's difficult to see, but there is 7 plots here. And it's important to say that this is not so far from a huge city that you have in Amazon. Is Manaus. I don't know if everyone is familiar with Amazon. Manaus is a huge city inside of the forest, and it's interesting to understand better the effect of human in the Amazon, the human impact of the Amazon. So you have all of this kind of area, 70 kilometers of the Manaus. This is the area, and we have different plots, 7 plots. Each plot is something like this. We have a lot of plants here, and with different species. Like we have 200 different species. It's like 30 meters of diameters, and around 50 meters of the height, each plot. This is a very heavy, how you people work inside, just to understand how is the heavy and the wild problem. So it must be interaction between instrumentation and people there. So this is the problem. Some instruments that you have a different instrument installed in different positions inside of soil and close to the plants. And this is some instruments that, for example, laser scanning, and just to estimate the forest biomass for monitoring this. We have some inside of ground, some monitoring the below ground fine roots with the mini rhizome camera. We have some shots. So to have this kind of data, this kind of instrumentation, and many of the instrumentation they generate some data during the operation. So this is kind of the data that we are collecting. For example, is diary and monitoring all the time. I don't know, 2 minutes. So just a brief presentation. I have some conclusions, some ideas about this kind of project. It's important, this kind of the project that has a lot of instrumentation, many people, many PIs is responsible for each instrument. It's important to because they must be very we must be very confident, we must be very trustable environment, because many people are involved in this kind of the experiment. So we must be very clear and real data policy, data management plan. This is very important, and aggregated instrument as a part of this. And who is the PI responsible for this instrument is very important to be this information linked with the instrument, because the trustability of the instrument, the data quality is very important, is who is the PI responsible for the instrument. This is very important. When I saw the metadata, I think this is, should consider this. But one important that we understand in this project, it's kind of this project has so strong international collaboration with more maturity institutions that work with this problem, like USGS. We have some people from USGS here, Vivi. We have strong collaboration with Oak Ridge National Laboratory that has more experience with this. We are working with them. NCI, of course, that very work with infrastructure, and more community involvement with understand the standards and aggregate these standards of what you are doing, and bring some requirements for these communities too, like RDA, CODATA, EZIP, AGU. One kind of this project, we must be prepared for evolution of the standards. NetCDF, for example, is a very important standard that we could consider in this kind of the instrument. And it's important to focus on data quality, and we must take care with the instrument, but the people that training that will manage the operate this instrument, they are very important, because they will guarantee the data quality. This is one thing that I would like, a message I'd like to talk in this session. Thank you very much. Sorry for the delay.
Thank you so much. Do you want to step over here to the chairs? That would
Okay.
be fantastic.
Okay,
And
step
then you
here.
can be part of the
Thank you.
panel as we are moving through the speakers. Charlie, you are up next, my friend. So let me introduce you. Let's see, is that your one more slide? Thank you.
How's the sound?
Oh, you sound fantastic. Here, let me give you a proper introduction. So Charles Catlett is the senior computer scientist at Argonne National Laboratory and a visiting senior fellow at the Mansueto Institute for Urban Innovation at the University of Chicago. He'll be talking to us about the environmental sensors that are within Chicago, and was recommended to us by Deb Agarwal, who helps manage the Ameriflex towers in the United States. So take it away, Charlie. Thanks for joining us.
Thanks for letting me come in from Chicago, where it's just after 5:30 in the morning here. I guess we're going to do since I don't have a clicker here, I'll just say on this slide here. Okay, so Shelley, you'll be my remote clicker.
I'm for
This
you.
is what I want to talk about today is not just urban environmental sensing, but some of the lessons that we've learned, starting with the city of Chicago and a project called the Array of Things, which was NSF funded, technology that Department of Energy has funded, and then a recent project that we're involved in now that expands beyond just cities like Chicago. You can see at the bottom of my slide, we have a huge team, and that's just the scratching the surface of the technical team. Our team includes scientists from around the country, another probably 30 names there. So let's just go ahead and jump in. Next slide. This is the slide from, I think, about 2011 or 2012, when we were talking to NSF and the city of Chicago and others about why we should instrument a city like Chicago. And there are two things that you see on this. On the left-hand side, you see the EPA sensors for the Chicago region. The blue area there is the municipality of Chicago, and then the larger area is metro area, Lake Michigan on the right-hand side there. This is a metro area of about 10 million people. The city itself is 2.7 or 8 at this point. And you can see there, if you want to know about air quality and health impacts of air quality or air pollution in the city or in the suburbs for that matter, you don't have the spatial or temporal resolution that you need. EPA sensors are great, but they're meant for regional general assessment of a region. So if you were to blow up the picture of the Chicago municipality there, you'd see huge parts of the city where we just don't have good information about air pollution. And so that makes it tough for the city to make decisions about policy, whether it's healthcare or other. On the right-hand side, as part of our project, we have worked with scientists from just about every discipline, especially with the Array of Things. We began with a series of workshops where we said to different science communities, hey, we're going to have an opportunity to put up a couple hundred gadgets on poles in Chicago. What would those gadgets do in order to advance your scientific agenda? So one of those things you can see here is pedestrian flow is of interest to social scientists as well as transportation people. And when I first saw this map, again, over 10 years ago, I thought this is great. They have excellent data about pedestrian flow, until I noticed the fine print that this was a survey that was done with, little clickers and people with clipboards on a particular set of days back in 2007 or so. So no real information in any city, at least at this time, of this type. So that's what motivated us to design a device from the science community. We got lots of different suggestions. We ended up with a device that had cameras and a microphone and about 20 different types of sensors. Let's go to the next slide. So this started us down a path of as of today, so 4 major projects, all with spin-offs and smaller grants. The first of which is this Array of Things project. You can see in the map on the right, there are about 150 of those devices that went out between 2016 and 2019, all around the city. I'll say in a few moments how we decided where to put those, but the first cut was to look at the city overall and try to get a good random sampling across the city. The second project, and one that we're still in the middle of, if you click one more time, Shelley, is the SAGE project. That's a follow-on to Array of Things, also funded by the National Science Foundation. And this gets us, not shown on the map here, but you'll see it in a moment, this gets us well beyond urban. The partners of the SAGE project, besides Array of Things in Chicago, are the National Ecological Observatory Network, or NEON, which is 80-something towers across the US, as well as in Puerto Rico, Hawaii, and Alaska. They're part of the US too, but not continental US. We're partnered with the ARM project, the Department of Energy Atmospheric Radiation Measurement User Facility, where they have LIDAR systems in in Oklahoma that we are connected to with some of our devices, as well as up in Port Barrow on the north side of Alaska. In the Southwest, we also have nodes in the Wi-Fi project, which is a project at UC San Diego, cameras on towers to give first responders information about wildfires. And then other sites around the world that we're beginning to partner with. And then just, one more click here. We partnered with Microsoft Research over the last 2 or 3 years to put smaller devices just doing air pollution on bus shelters throughout the city, 115 of those out of the small percentage of the 2,600 bus shelters in the city, but a good start. And then we just began a project last fall called Crocus, that's DOE funded. It's a $25 million 5-year project to look at and measure and model the impact of climate change on urban communities. Shelley, next slide. And if you could tell me when I have 2 minutes left, then I can adjust things. Just a few examples on the previous slide, if you're able to go back, of what kind of things that we do. So the unique thing about Array of Things and Sage and our platform is that we have multiple computers out there with the sensors that are doing that are programmable, and we send in containers, we send software out there to do things like image or sound analysis. Here you see some image analysis examples from looking at, is this a cloud or is this a wildfire, to the pedestrian and vehicle flow, looking for flooding, etc. I don't have any examples on here of sound. I should have put one on. We do have, we've taken the Cornell's algorithms for differentiating bird calls, and we have those running in certain nodes, not in the city of Chicago because of wiretapping laws. But there, as I've been talking, you've been reading the list on the left there of all the reasons why we decided to build a much more difficult device, a much more complicated and fragile device than
2
a
minutes, Charlie.
typical sensor. So that is my 2-minute warning, Shelley?
Yes, that is.
Okay, next slide. I mentioned that we run software at the edge. This is our app store. And each one of these you can think of as a software-defined sensor. And so it is an instrument, a software instrument, that is putting out some stream of data. Next slide. You can see the map in the upper middle there of where we are across the US. The dashboard on the right-hand side gives people, now I start to talk about the data, gives people access to time series. You can, like any sort of Grafana type site, you can interrogate the data. A schematic of the node at the left, click one more time. It's a little bit messy with the font change from one file to the other, but I think you can still read it. Every time one of these devices chirps a sensor reading, it's an individual reading from an individual sensor, and you can see this metadata. I'll come back to this in the next slide when we talk about how all this relates to FAIR and some of the lessons that we've learned. So next slide, let me just close, and there are some additional background slides that I provided. A couple of things. One is we've already learned that we have to replace devices because they fail, or we have to replace them because a new device comes out. And so we have to keep track of the device and where it is. And at a given place, there'll be multiple generations of devices. We keep as a sort of sacred number the raw reading from a sensor, which is usually something like a millivolt or a microampere. And then we translate that into parts per million or temperature, relative humidity, or what have you. And it's important then to include that translation algorithm in with the data. How did we get that number? So we keep that translation, we keep the raw number. With the software-defined sensors, it becomes even more tricky because those are typically a machine learning model that is running a convolutional neural network that's doing computer vision, and those drift over time as they get better and they get trained. And so what we're grappling with right now is how to include with the, let's say we have a software-defined sensor that just counts the number of pedestrians every 30 seconds at a place. How do we include it's probably a DOI or something like that to the model that was used to produce that data. And finally, I would say we interpret FAIR in a little bit more broad sense than the typical science community, in that our partners are urban communities. And so you'll see, if you want to flip through these slides later, you'll see some of the things that we have done to make this data more legible to the people who live and work in Chicago, not just to the scientists. So I'll close there. Thank you, Shelley, for the skillful slide advancing.
My pleasure. Thank you, Charlie. And let me hop forward. Deborah, do you want to come forward while I'm how many slides is it, Charlie?
Just 3 or 4.
3 or 4. Okay. All right.
You're almost there.
You animated it, Charlie. I can't wait for we get to discussion, because I have a bunch of questions for Charlie on this. Okay, I'm still going. Come on up, Deborah.
Yeah, that's the last one.
Okay, cool. Great. Thank you. There we are. Okay, fantastic. Deborah, come join me up here. I want to introduce you to Deborah Drucker. She's a data specialist at Embrapa, Digital Agriculture, one of the Brazilian Agriculture Research Corporation research centers. And she is here to talk to us about her project around airborne LiDAR. And I'm very excited. So advance here, and I'll step off to the side.
Thank you, Shelley, and the organizers for inviting me. So this is probably a more simple case, but I hope it will also contribute to the discussion. So we have this project that actually just ended, and it was a 10-year project on our airborne LiDAR in the Amazon, and also other 2 biomes in Brazil. So the LiDAR is this, probably most of you are familiar with, and also it's shown before here. It's light detection and ranging technology, and it was the main objectives of the project was to understand forest degradation and biomass estimates and carbon stocks. And it was a partnership of Embrapa, the institution I work for, with the US Forest Service, and also it was funded by USAID and the US Department of State. And one of the main objectives of the project was to disseminate this data for anyone interested, basically because it's very expensive to collect data like that. And also more difficult in remote regions. So we had funding to build a platform to deliver this data. So this is what we have now. Our team at Embrapa already told us that we need to get rid of this because it runs in an old version of Ubuntu and it's vulnerable, and we are changing. But for the discussion here, what I think it's important is that we have the data available in this platform, and so you can zoom into the different areas, and we have data from 10 years, so there's different years. And if you click in the metadata, you will have more information. This is a Agile Network catalog, so you will have more information on the data set. And this is how we deliver the instrument data in the supplemental information field. So when we started working with this, we talked to some colleagues in the Earth System Information Partners, and nobody really had a solution, and we just put it in this field, which is not so, probably not the best solution. And the important thing is that this is how we receive the data. So the vendor delivers in like a Word doc document the data on the instruments, and then we have someone that is go there and type this. So now we are moving to our Dataverse installation, because we need to stop the old system, and we are putting this in the notes field. So the only difference is that the software that used to be in the supplementary information, now it's in the software field, but the instrument data is all here. So I was glad to see Rolf's presentation. I think it can help, but I think that the main, when Shelley and Christina talked to me about this session, and we discussed a little, this example, it's not very common for us because most of the projects don't have this money for data curation, and the way that we did here is very prone to human errors because someone typed in from the vendor and then someone typed this for us. And as I said, we probably could have documented this in a better way, but that's what we could do at the time. And I also talked to other colleagues at Embrapa that deal with more diverse sensors, as the one Pedro showed, or Charlie. And most people won't have won't be so much worried about typing things in the metadata. So ideally, this would all come from the vendor and already in a standardized way, and it would just be ingested by something like Dataverse, and probably that's a better solution than typing. So I hope this is good for the conversation, and thank you for your attention.
Thank you. Please join us over here. Thank you. So the puzzle continues to build. So our next speaker, Stuart Chalk, I've known Stuart for quite a long time, and you'll notice that we are a little biased on the Americas and we're a little biased on environmental and earth and space science stuff, but just know that we expect that there will be other use cases. But I do happen to know somebody within the chemistry space, so come on up, Stuart. Here, let me introduce you properly. Professor at the Department of Chemistry at the University of North Florida, also part of the IUPAC Committee on Publications and Chemical Data Standards, and that's how we met each other.
Yes, indeed.
And I'll let you take it away and help give us some other kind of discipline to talk about here with instruments.
Okay.
And you probably have to advance.
Okay. All right. Thank you, Shelley. When I get back to the United States on Monday, and I talk to my students, probably one of the things I will say is funny things happen on the way to the RDA plenary. The way I say that is because a couple of weeks ago, Shelley emailed me and said, "Hey, would you like to be part of a panel discussion?" And I was like, "Okay, yeah, that sounds fine." And then this morning I got an email that said I was actually presenting. So these slides have been whipped up pretty quickly. So they actually follow on quite nicely in the sense that we've gone with very sophisticated, complicated, long studies with lots of data, lots of money, to here where I'm going to talk about, in a very general sense, chemical analysis, but also weave in some other things that I'm involved in that I think are useful in this conversation. So hopefully this makes sense. So I'm a trained analytical chemist. And one of the things that's always been an issue since I was a graduate student is the quality of the data coming off an instrument. And once I had done my PhD and kind of really seen what industry really needed, it became clear that the data systems of that time and the data systems even today are still not necessarily lagging behind, but
but the vendors of instruments have more of a focus on obviously making their instruments look good than necessarily providing maybe all the data that a user wants, unless you buy their software, okay? And you have to buy their software to run the instrument. So, so the comment here is, there are a plethora of analytical instruments. And so I'm specifically talking about instruments that are purchased and placed in chemical labs for doing some kind of chemical analysis, whether that be in environmental testing, whether it be in pharmaceuticals, trials and that kind of stuff, whether it be in petroleum industry. There's lots of different industries. The analytical instrument kind of scope globally is estimated at $50 billion US this year, and it's going up at a rate of like 8%. So there's a huge number of these instruments. If we think about those instruments and we think about the idea of having persistent identifiers for them, my reflection is that yes, we maybe do want to have one. Absolutely, we want to have an identifier for an instrument, but then the question becomes: do we even need identifiers for peripheral or smaller pieces of that piece of instrumentation? Because a lot of these instruments are quite sophisticated. They do break down, they do get serviced, and so there's pieces that may get replaced over time. So again, to accurately represent in a digital sense an instrument that was used to make a measurement, we kind of need to think, about what we mean by the instrument in that sense, okay? In addition to that, we need to contextualize the measurement, and that involves, well, what are the environmental conditions under which the instrument was used? Obviously, if it's a lab setting, that's a much better controlled, we hope, environment than if it's out in the real world. But still, you have to make those measurements to ensure that you have, you capture the characteristics, because if something goes wrong with an instrument, or you are doing a long-term standardization or calibration of that, and you see trends, you definitely want to look into those, and you want to decide, what are the variables that have contributed to those trends. So you have to worry about humidity in the lab, you have to worry about temperature. You may also have to worry about power stability, because that can influence the quality of the measurements off of very sensitive sensors. From a calibration perspective, you absolutely want to look at the history. So you can look at trends, and this is done many times a year in many sectors, to make sure that instruments are performing at the same level and they're getting the same quality results. And then, like I said, service records. Has something been serviced recently? And if it had been, was there anything that was changed? Is there a change in the calibration of the instrument based on the service that was done because of, they improved one particular component that was replaced or something like that? So there are many things to think about in this context. In addition, there are problems, like I said, with instrument data, and some of these comments that come out of discussions with Bob Hanisch at NIST, where they're deploying a lot of instruments, and some instruments sometimes don't report data with units, which is kind of bizarre to me, but that's sometimes what you see. And sometimes you also see measurements that are represented with a very large number of extra digits that you really obviously can't realistically rely on. So the quality of the data that we get from the instrument itself is important. And then the export format is also important, and that's where we maybe need domain standards. And I give an example here, which is an IUPAC standard, which is called JCAMP-DX. So there's a lot of pieces to unpack here to be able to do what I think is a great idea, which is digital first collection of data all the way to citation. Three other quick things that I want to introduce here. One is this IUPAC project that I'm part of. It's colloquially called the FAIR Spec project. It's about spectroscopic data specifically, but the idea is that once we've gone through this analysis in this project, we will take what we've learned and see what we can do to make it a bit more generally applicable across different techniques. But as you can see here, it's about how do we make this type of data fair in a very general sense? What do we need to do as a discipline to understand how to make that data fair, or convince the vendors of the instruments to give us data so that the data is actually more fair in a general sense? The second piece here is another facet of my interests, I mentioned Bob Hanish, who's in the audience here. He's the chair of the Digital Representation of Units of Measurement working task group under CODATA. He and I are also members of this expert group within the CIPM's, associated with the CIPM's task group on the digitalization of the SI. So this is a very quick slide to say that from a perspective of representing units of measurement and actually other metrology concepts, in addition to incorporating that in data that you're getting off of instruments, there's an effort now to move towards a digital representation of those units and quantities and other metrology concepts. And so from a digital first perspective, this activity, both the formation of this, what's going to be called right now called an SI digital reference point, where nominally we will actually have unique ways to reference to the individual units of the SI. And then this other piece called the Units of Measurement Interoperability Service, where there are actually lots of ways right now in different communities where units are encoded in different ways. But how do you, in a sense, how do you know that one encoding in one flavor is the same unit as another encoding in another flavor? So we have to bring those together, and that's what this effort is all about. So again, this slide is, think about fair. When people say fair data, think about fair data really means data that has fair units with it, because otherwise you don't have the right context of your data. And finally, one thing that I've been working on over the last few years is a way to kind of encapsulate, in a semantic sense, generic scientific data. And that's this approach called the SciData framework. It's too difficult and too complicated to try and explain in detail right now, but the basic premise is simply that if we think about scientific data in a general sense, we can kind of look at research papers as they're typically published, and we can say, there's metadata in the methodology or describing how a piece of research was done. There's metadata in the type of thing that you study, the system. And then of course, there's the experimental data. And if we think about scientific data in a very general sense, kind of like categorized like that, we can maybe put that into one nominal format, or at least try and put it into one nominal format to express it. And so the very complicated picture on the right-hand side here is kind of the general kind of map of how the pieces fit together. This idea has an ontology referenced to it, so that it actually builds a structure to be able to host this data if you convert it into semantic triples and put it in a graph database. And so the general idea is, yes, not only get data from the instruments digitally, but also make sure we capture that in a way that it is semantically represented so that we can actually do really useful things with it, okay? So the last slide here is just showing you an example of this. And this is probably very difficult to see anyway, so I won't focus any time on it. But the point is, we can put a lot of different metadata in here and represent a data set the way it actually should be represented, rather than trying to cram it into one particular format. Okay, I think I'll finish there.
It's over here. Wow. All right. So thank you for bringing in chemistry. That was really helpful. I think we just have a generic slide, or none. Okay, looks like none. So we'll maybe back up to something useful. Oh, perfect. Thank you. Look at that. Good. Yes, Rolf. And I think, Keith, you should come up too. And Edith has the questions. All right. We'll take care of the questions. I'm sorry. So if anybody online has a question, please go ahead, either type it or put your hand up. I'm not sure if I can see hands, but I can definitely see typing. Oh, I can see hands. Keith is watching for hands. Okay.
Yeah.
So Keith is watching our online. Edith has in room. Okay, you got it. That's our hybrid space. Is there a first question, or shall I? And Charlie is online too. So Charlie, you're here. Don't. Yeah, there you go. All right, good. I see you. Oh, wonderful. That looks fantastic. Oh, only I can see you. Okay, great. He's here. So one of the questions that I have, I'll kick us off, is I'm not 100% sure this applies to what Stuart's talking about, but in my mind, the instrument and its location. During one of my conversations with Deb Agarwal and separately with Charlie, it was, listen, we have this spread of instruments, but if one fails, I'm going to replace it. It may not be calibrated exactly. You need to know what exactly that instrument was and where it is at all times. And I imagine there's a number of things. Charlie, do you want to jump in on that? And thank you so much for being up so early.
Oh, sure. I'm a little self-conscious because I'm like 6 times the size of anyone else on the stage. Sorry, guys down there, small people. You know, the early on, we got bit by not having GPS in our devices because we just sort of underestimated the amount of effort it would take to just keep track of hundreds of devices and things being replaced and sent around. So we fixed that after the first spin of our devices, and that has served us well. So to be able to query the device and ask where it is a very useful function.
Great. Does anybody up here on the stage want to add to that? Of course it's important, Shelley. Move on to the next question. All right, got it. Super. So so there was another example that came to mind. And so while all of you are in listening, participating here or online, the bottom question for this entire effort is, do you want to take this further? Do you see there an opportunity here at RDA to create potentially a connection to CODATA, a connection to other efforts? Do you see there being work here around a recommendation? So just realize that that's the big question at the end. We are exploring at this point. This is a hidden BOF because we're talking about things that aren't really sitting within RDA as a current working group. So if you came in late, that's the premise here. So data coming from an instrument born as fair as possible, and what do you need to know and what needs to come from the instruments and what do we need to do as we go forward. So there's your orientation in case you lost the bubble on all of this. But one of the, I was talking to a colleague who works at NASA specifically within their life sciences. So these are the experiments in the people and animals that are on, say, the International Space Station or potentially going to Mars. And they're working towards this, but one of the challenges was if I'm doing a particular experiment and it's important to me to know the orientation of the vehicle, the radiation that's coming in, and as that would impact the experiment. And at the time, I don't know if anybody's on the line from that organization, but it wasn't ideal. It was very manual to figure that all out. And I think they're working towards a way to have interoperability. But I imagine that plays in different ways. You were talking about humidity, Stuart, so that there's a role there. And almost the opposite is happening within the Amazon and in Chicago, trying to measure the humidity. So not just the instrumentation's impact on the humidity, but at measuring the humidity. Anybody here on the floor that would like to talk to that, please?
Okay, I'll jump in.
Great.
To my mind, you know, if we're going to collect any type of data, we have to capture as complete a set of contextual metadata as is necessary. You know, you don't get, well, let me rephrase that. The quality of data is not necessarily just about the quality of the measurement. It's about the quality of the representation of the context of that measurement as well.
Oh, wow. And we were recorded and we can write that down.
Oh, geez. I said something now.
So if anybody wants to help with the charter for this working group, that will be in the charter. Dang, that's a great one. Charlie, do you want to add to that?
Yeah, you know, with these sensors we put on bus shelters, there's a temperature sensor inside, and similarly with the Array of Things devices, and that is you know, it's affected by the amount of sunlight that hits the device. And so with the Array of Things, we had a light sensor on the top so that we could at least have some idea of the context of the temperature measurement. Is it in the shade? Is it in the full sun? With the Microsoft devices research devices on the poles, there is a solar panel, and unfortunately, the device first round anyway wasn't designed so that we could get that data, but just knowing the solar radiation from the output of the solar panel would help us to calibrate that temperature sensor.
That's pretty awesome. Do we have a question in the room? Oh, yay, we do. Great.
Bob Hanisch from NIST. Not so much a question, but I think the PID for instruments is probably one of the most important outcomes from RDA that we've seen in a long time. We have PIDs for people, we have PIDs for data, we have PIDs for documents, we have PIDs for organizations and so forth. And we were missing this really key piece of information that's essential for assuring the fairness of research data. So Ralph and your colleagues on the PID working group, thank you for this. At NIST, we are in the process of taking inventory data for our instruments, 500 or 600 that we have in our laboratory in MML, and mapping them into the PID inst metadata schema. And I think this is just a profound outcome of RDA. And I encourage all of you who are dealing with instrumentation to please adopt the PID inst schema. And I hope that we can actually move this forward to even a more formal kind of standard that can be recognized by the international community broadly. No question there, just a comment.
That's a brilliant endorsement and adoption case right there.
Summarize Bob. He wished to have a working group on this. Yeah, so it's a good
Very
thing.
good.
Yeah.
Just
Australia.
as I see Francois and I see back.
Australia is the
back.
next.
Yeah.
And with a rather historical comment, just going back to the context of the measurement. I'm harking back to when I was a young child with my scientist father, and of course we always had a Stevenson screen around the meteorological measurements. You have all sorts of. We have always had controlling factors, modifying factors to really properly interpret the data that's coming out of the instrument. And this is nothing new, but because we're all racing forward, I suspect we have been often forgetting it. And I won't mention particular cases, but anyway, that's just a statement. Does anyone think that's really silly and basic?
So I see Vim in the back and
I go to the back then.
okay, and Francois up here as well. And this gentleman right here.
Thank you. Just a quick question. We talk a lot about PIDs for instrumentation, the fact that this change, evolve, get service. Have you thought about how to connect with configuration management systems in order to even add more detail about this instrumentation at a certain moment in time and how this change?
Anybody on the floor? Oh, you put me on the camera. Thank you, tech people. I was trying to hide. Anybody here on the floor have an answer there? Configuration management systems?
Yeah, I mean, any say technical description of the instruments and any say modes of how to operate them is necessarily say community specific and specific to the scientific domain. So this is not something that you could put into the PID record. But the key thing I believe is the ability to link different entities of information. So of course you could have your say domain-specific description of the instrument, including technical specs and everything, and link that from the PID record with relation to past metadata, and then you would be able to find that back from the PID record.
Yeah, my background's in software management, so I vibe with the configuration management comment, but we can always put that into a nice package. We can talk about the configuration. We can actually run that as a script. But when you introduce instruments, it's different. So I imagine Charlie has a homemade, you said you were doing a lot of the work with the instruments in Chicago just because it made sense. So I imagine you have a way to actually track configuration of what's where and how it's configured.
Yeah, one thing that we think about our nodes, which have lots of different devices connected to them, sensors and cameras and other things. We think about that as an aggregation device, but when we report the data, we report the data from a specific sensor, and its context comes from the node that it's connected to. So that little snippet of code in one of my slides, when the sensor reading comes in from, let's say, a relative humidity sensor, it comes with information about the device that it's plugged into. So configuration management happens when you add that sensor to the device, because there's a plugin, a standard plugin software script that you have to write to plug that sensor into the node, and then the node management knows what's there because of the plugins. So there's registration.
It's the same, but a different solution, more like what Rolf's talking about, how it's linked.
Yeah, actually, so this is also something that we have foreseen in the schema. You could have a hierarchy of instrument. You could have a complex instrument that is composed of multiple sensors, and then of course you could attribute a PID to each of those, including the component, the compound instrument, and also link these PID records. So this relationship has part or is part of.
Indeed. Do we have another question? Ah, right here. Go ahead, Françoise.
Yes, Françoise Genova from Strasbourg Astronomical Observatory in France. So I have, listening to you, astronomers do observations, and we have been trying to describe them so that they are usable forever, maybe something like that. So I have a feeling that what we see around the table, it's your own experiments, what you have done, and what we try to understand is the communalities and the building blocks of a description of it begins in our case to a telescope, then there is the instrument on the telescope, and then you have what happens is the air transparency and turbulence at that time, and so on. Which time was it? And then you have the units, and then you have what happened to the data until it goes to the database. And then you change the computing system and you need to keep track and so on. So I have the impression that it would be useful to think about these building blocks, and I have a feeling it's what you had in mind. I have another one, which is another of a recent RDA result recommendation, which is called eAdopt or iAdopt, I don't know. I can read you what it is about. A common way of decomposing variable descriptions according to a systematic approach that clearly identifies essential atomic components of these variables. And they have examples, and it has to do with what you have done. So I have a feeling if we put knowledgeable people in the same room, we could build a schema of the different elements to define, to go into a provenance, going deeper into what provenance means when it's an observation. And I have a feeling there are people who could participate in that in the room.
Yeah, we had the iAdopt presentation in the semantics group just yesterday.
Okay. Shelley, do you wish to get answer? Because we have other 2+1 question.
I think that would be great. Go ahead.
We have a virtual question. Is now a good time?
Anybody want to comment, Charlie, or anybody here on the floor about iAdopt or the comments?
I think that's a great idea. I think the next breakout after lunch, there's an iAdopt session. So if anybody's interested in that, attend.
All right.
You'll see me there too.
Okay.
So
Perhaps
maybe a virtual question, and then we collect the questions here.
Okay. The online question?
Okay, the online question. So this is about standardization, and so I'll try and read it out. The PID-INST is an excellent advance, but it's still very much in its home ground regarding use cases. I think instead, sorry, I'm paraphrasing. I should paraphrase here. So this is a question raised by the convener of the Australian, which is probably why she's not here, a community of practice around instrument for identifiers. So the question was, instead of a, what about instead of a wider standard, we can look at implementation of the PID in schema rather than a PID for instruments. So, for example, Australia's just put out a best practices document for persistently identifying instruments. I hope the question's clear. So it's the question rather, do we adopt quite narrowly PID-INST, or do we encourage a best practice in persistently identifying instruments?
So I think that's the adoption that the PID instrument working group would be working towards. So we do have that effort happening,
Yeah,
I believe.
in a sense, that is what we did. So we described what you would need to persistently identify instruments. We did not invent a new PID type. So we explored using existing PID infrastructures and how to describe best the instrument within that infrastructures in order to identify the instrument.
So whoever's online, if you could just confirm that answered your question, that would be fantastic.
Meanwhile, we collect the other two.
Next question coming up in the room.
Hi, Mark Parsons, NASA Science Data Office. This is a pretty naive question, but it builds from your comment, Stuart, about the sort of proprietary software that goes with instruments. So I really like the sort of nascent proposal that Shelley put forward for a working group, but is this even possible without including the instrument manufacturers for the generic instruments, or is this can this only work for our sort of bespoke instruments?
I think you hit a good point there, that we need to get the vendors involved clearly in this discussion.
But do they have any incentive? Because I mean, there's an incentive for them to keep their locked proprietary format, right?
In a sense, there is. This has kind of always been a topic of great debate within the analytical chemistry community, because there are some situations where there's only actually one vendor of instrument type. So
can you go to Vim, please? He's been waiting.
Yeah.
So the answer is, I mean, there's been a lot of discussions, again, specifically from analytical chemistry in the lab instrument space of trying to talk to the vendors to give them not only the incentive, but as I think was mentioned, actually give them the schema almost of what the data is we want out of the instrument, in addition to the experimental data, all the conditions and all that kind of stuff. And that may be actually the wrong way to go about it. I think it may be that what we really need to do is show the scientific community, this is what you should be going towards, and then don't go to the vendors and say, I'm not going to buy your instrument unless you don't support the model that we have. Yes, that's possibly the way to go.
Yeah. And
well, I can comment from my biological microscopy field here. Marek Cwiecawer, Czech Academy of Sciences and Eurobioimaging Advisory. The Quarep group in Germany, and it's actually global, managed to get involved microscopy companies into the development of standards and everything. The reason at the end, of course, at the beginning, it was only one or two companies, but at some point it became advantage for everyone to join this run, because those companies which didn't adopt to the standards from these groups were simply not selling their products.
Yeah, so there's a use case. Yeah, there's provenance or precedent there. That's the word I wanted.
And I'm coming to Wim. Yeah.
Yay. Next time, Vim, sit up front.
Yeah. Thanks. I'm Wim Hugo from DANS. So just looking at what the working group should also put into its scope or its charter, to my mind, we are, let's say, good research practice asks of researchers to record the context of the instruments, the calibrations, the way in which they were set up, the standard methods that were used. So the question to ask is, to what extent must all this stuff be machine readable and actionable, and why? Because that's the problem. It is a huge undertaking to provide persistent identifiers for each calibration, for each scientific, well, the assessment methods, maybe not so much, but certainly the context of each individual instrument is a massive undertaking to encode. And we should seriously ask to what extent one needs to do this. The main motivation, I think, is reproducibility, but how much of that needs to be machine actionable?
Yeah. Yeah, and I could imagine the argument being different angles depending what your discipline is, the type of data, the type of instrument. Yeah, that's a really good point. And with the overall hope that you're also reducing the amount of time it takes for researchers to do all of the things they need to do with data, because if it's more fair as it's being generated, you're saving time in other ways as well. So I feel like there's a really great value statement there.
Anybody wish to respond to this?
Again, I can chime in from analytical chemistry, where in a context of doing an environmental analysis of nitrate in a water body of water, there is a standard procedure. In the US, it's from the United States EPA. I could see that being translated into a protocol which nominally could be executed, but that still might take a little bit to do. But then the question is, there's nearly always some kind of subtle change, or just the context of some individual analysis where that protocol is followed, but then there's some difference. And so you have to be able to record the individual changes that happen, even though it's nominally with one suggested required protocol that's under work. So you'd have to be able to capture all of that. It would be very interesting to go along with that. And there is a website called protocols.io. I'm not sure how many people in the room know of that, but I know of it, but I don't know much of the detail about how they in that particular situation represent individual protocols. But I assume they may be going down the path of machine readability at least.
Yeah, good point.
Questions from here from this floor?
Yeah, hello again. So I will agree with Pim's input about machine actionability. So in order to be fair, it is important that the PIDs of the instruments resolve to something that is machine actionable and understood by machines, and also have the minimum metadata that are needed to represent what you need. So make sure that what you need is there, and you don't ask people to put more metadata that you are never going to use. And the other point is Stuart showed the method, wasn't it, about an instrument, which is something that we are also looking into. So reusability is another thing. Do not reinvent the wheel. Try to use what already exists out there, so that you are more interoperable with other people that are already using what is already out there, to be really fair.
Absolutely. Yeah.
Thank you, Alexandra.
Yeah, would you so kind? I cannot.
Hello, yes, so Brian Matthews, STFC. So I've just been finishing off a project with the called Expands with the photon neutron community in Europe, where we've been looking at a FAIR toolkit for that community, looking at whether how we an experimental process from an instrument on a beamline generates a FAIR data, and it is very much about a FAIR process, not just a FAIR data set. And as part of that, we've done the FAIR assessment. We've done a lot of recommendations on tools and processes we should use, including the use of persistent identifiers for instruments. We would also recommend persistent identifiers for things like samples. And as part of that, we've done a lot of work on analyzing what you might need to put in a data management plan for fairness for a particular experiment you're doing. And you get on the analysis of that, we have a list of over 90 questions that you could reasonably ask to give a complete context for an experiment, which is a completely vast number that you're not going to get any realistic scientist to complete. So I think we have to think about how we collect that information in a reasonable way. And persistent identifiers for instruments is one way of doing it. We can get a lot of context about the instrument from the persistent identifier, but also to embed the data collection, the fair data collection in the process. So we're actually collecting it as we go along to collect that as much as we can through a machine readable way. So we can actually minimize the amount of information we can reasonably expect to collect from the user to actually put in, because they're just not going to do it otherwise.
So I feel like what you just said is the actual purpose that we would have for the working group. How do we do this to actually minimize that, to help with reproducibility, to help with transparency, to support all of the other processes downstream, as well as what's happening within the research lifecycle of the instrument. So you almost summed up everything right there in that lesson. So all right, we're coming to an end. We've got 3 minutes left.
So I have a question.
3 minutes, my friend, 3 minutes, hurry up.
Yeah, so my name is Edith Herzog and I'm a third co-chair, and I have got 2 questions. Yeah, the first one, the first one is that if there is a dilemma, if the vendors would be interested to be here or not, I think that they would be interested. It's quite easy to put together the value proposition for them. And I think it was quite well summarized by Marek. So the first is a suggestion that we have to invite some of the vendors, the most innovative ones, because it's a great opportunity for themselves to differentiate better and to move away from the Stone Age to typing and actually using the researchers to typing. Yeah, I think it's just a lost efficiency.
All right,
yeah?
I'm going to cut you off because we are at 2 minutes now.
Yeah, no, so
all right.
Yeah. So,
So
that was my first suggestion, that we invite the vendors. Yeah, that's the first one. And the second one, that I think that this working group now is almost ready to go. My question, that how we can use the fair data maturity model to maybe follow or measure the success and give the request to the vendor.
I think that is absolutely brilliant. So let's see if we can get the working group stood up. Okay. Show of hands, feel free to do this online as well. Would you attend this working group? Okay, come on. I'm not going to hold you to it. Just go for it. All right.
Any more?
Would you be a co-chair of the working group? Yeah, no. Right. So if you would be willing to attend the working group, please make sure your name is in the collaborative notes for this session, please. And we will send out an email and start to pull and see if we can find somebody who'll be a co-chair. It really needs to be somebody who's within, one of our speakers, for instance, Charlie. This is a good time to join RDA. So this would be really fantastic if we could find someone who's in, working directly with a number of different vendors who may have those personal relationships where we can actually invite in a kind and opening way for them to come as we tell them what we want them to change. That's going to be fun. And it would be great to be collaborative. So all right, if you secretly want to become a co-chair, but won't do that in front of you, 100,000 peers, please just let us know and we'll work with you on the charter. So thank you everyone for coming. Thank you all of our speakers. Charlie, thanks for being up incredibly early. We really appreciate your participation and have a really great RDA.
Thank you.